Fixing to start again. Chapter 13. Chapter 13 is a little more in depth, so that's why I kind of took a break. Y'all need to take a break too. Let's think about this a minute. Um, we're going to kind of bump it up just a tad and kind of start trying to, look at our problems and decide what's fluff, what we need, what we don't, what we're really solving for. So let's just start calculating flow rates for IV infusion. Um, let's just look at our example one. I think sometimes that's just the easiest to start with is looking at problems. So the provider order reads, and again, the provider would be our doctor, nurse practitioner, whoever. Infuse D5W, 1 liter over 10 hours. The nurse should set the pump or controller to what milliliter per hour flow rate. Round the flow rate to the nearest whole number. Okay, so it says in our little note right under it, set up the equation, use a dimensional analysis principle. Note that the unit contained in the answer must be in milliliters per hour and is not in the information offered in the question. So, ding, 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 the missing information should be a clue that a conversion factor is needed. Okay, so we got to think a little bit. So, um, we need to use milliliters per hour. So we have 1,000 milliliters in 1 liter. Is that not one of our conversion factors that's on our trusty conversion sheet right here? So, thought you were through with it? You're not. Pull it back out. Okay. So, milliliter per hour is 1,000 milliliters to 1 liter. Insert the given quantities. We know that we have 1 liter to 10 hours, and then that would equal to 1,000 milliliters to 10 hours. It would be 100 milliliters an hour. Now, yes, you could do that in your head. I know. But if you do it dimensional analysis way, when it gets harder, you don't have to worry about all that calculated, okay? So, shortcut, convert the volume in liters to milliliters first. This is a shortcut right below that you could do. This will eliminate the need for conversion factor, 1,000 milliliters to 10 hours, 100 mils an hour. Okay. Um, so remember this because that's get confusing a little bit on problems. Highlight, star, whatever, the note right there. The only information that is needed to calculate a milliliter per hour flow rate is the volume of liquid to be infused. It doesn't matter what it says about the problem, about the medicine. All you're looking at is the volume. Okay. So let's look at the next problem. The provider order reads infuse LR, which is lactated ringers, 500 mils over 2 hours. The LR we don't care about. The nurse should set the pump or controller to what milliliter flow rate, round the flow rate to the nearest whole number. So all we're concerned with is 500 milliliters over 2 hours. So milliliters per hour equals 500 milliliters over 2 hours, 250 milliliters per hour. Okay. In this example, the volume to be infused is given as milliliters. So no conversion factor is necessary in this equation. So the next one, the provider order reads infuse 0.9% of sodium chloride, 2 liters over 24 hours. The nurse should set the pump controller to what milliliter per hour flow rate. Round the flow rate to the nearest whole number. So we know 1,000 milliliters is in 1 liter. We need to do 2 liters in 24 hours. So you see how that problem is worked out. 1,000 milliliters times 2 divided by 24. So 1,000 milliliters times 2 divided by 24 is 2,000. 2,000 divided by 24, 83.3 mLs per hour. We're going to round. So you know if it's what? 5 or higher, we round up. Below 4 or less, we're going to round down. So 83 mils an hour. Okay. Those are pretty simple. Let's look, then you've got some to practice. Let's look on down to 220, example 1, down there, calculating milliliter flow rates for intermittent IV fluids. Okay, whatever. All right, same thing really and truly, but let's read this problem and I'm going to point some stuff out to you. The provider order reads, provider again, who is the provider? Doctor, nurse practitioner, whoever's writing the order. Infuse 350 milligrams of Glanvir, which is cytidine IV, diluted in 100 mils of normal saline over 60 minutes. The nurse should set the pump at what milliliters per hour flow rate? Round the flow rate to the nearest whole number. Now, in this problem, 350 milligrams of Glanzavir is fluff. Remember I told you on these type of problems we're looking, remember that little note back on page 219, the first note? The only information that's needed to calculate milliliters per flow rate is the volume of liquid to be infused. Don't worry about what the medication, how much medication, okay? So all we're worried about is the 100 mils and the 60 minutes. So mils per hour, we have 100 mils in 60 minutes. Then we have to use a conversion. We know 60 minutes is 1 hour. So that is going to equal what? 100 mils per hour to get it all in. We could probably figure that out in our head, but this is just showing you the dimensional analysis of ways. Okay? So it goes on with a note. In this example, the question seems to have 3 relevant pieces of information: the dosage of Glanzavir, the volume of IV bag, and the time of infusion. However, underline this, the Glanzavir is not needed to calculate the flow rate. So although the dose need to be checked for accuracy, we don't have to use that to calculate flow rate. Okay. So same thing. Here we go. The provider order reads infuse 500 milligrams of zithromycin, Zithromax. Azithromycin is what they've been using for COVID. One of the things. Diluted in 250 mils of normal saline over 3 hours. The nurse would set the pump at what milliliters per hour? Round the flow rate to the nearest. So do we need to worry about 500 milligrams of zithromycin? No. All we're going to worry about is our milliliters and how fast we need it to go. So we have 250 milliliters. It needs to go in 3 hours, and that's going to give us 83.3, which is going to be 83 milliliters an hour. Okay. All righty. Pretty clear. So then there's some other ones. If you read the number 4, the provider order reads infuse methoxyflin or Avalox 400 milligrams diluted in 250 milliliters, a 0.8% sodium chloride solution over 60 minutes. Fluff, fluff, fluff. What's fluff? The 400 milligrams is fluff, and 0.8% sodium chloride is fluff. All we need to know is 250 milliliters and the 60 minutes. Okay, so you got to start picking out fluff. Okay, that's what I call fluff. Start picking that out. Work through all these problems. Okay. Pay attention to the IV piggyback hints. That might help you as we go through some of this. Just kind of read that. You can work some of those extra IV problems there on page 222. They will help you. Your answers are in 246. It is wrote out. So if you are struggling, please look at those. Calculate milliliters per hour flow rates for syringe pump. Syringe pump is it's actually a pump that you could put this on and it's like a little, you always have to, I don't know what, it's like a different type of IV pump system, but you could put this syringe on and infuse this syringe into your patient. Okay. You have to have it set up with proper tubing and everything, but you could do that with a syringe pump. Many syringe pumps may be programmed to deliver medication in flow rates other than milliliters per hour, such as units per minute or micrograms per minute. But that's how they would be programmed. You can use micrograms per minute and stuff like that on syringe pumps. So we're going to start trying to figure out micrograms per minute. I know you wanted to shut your book and go lay down, but listen to me a minute. It really, the more problems we work, it will be easier because it's all dimensional analysis. It's all going to follow, okay? I've set the basis. If you will do it dimensional analysis way, there'll be no guessing, okay? So let's look at example 1. The provider orders reads infuse ampicillin 100 milligrams. And remember, we're figuring out fluid here. Diluted in 5 mils of sterile water over 15 minutes using a syringe pump. The nurse should set the pump at what milliliters per hour flow rate, round the flow rate to the nearest tenth. Set up this equation as shown, calculating milliliters per hour. Flow rates for intermediate IV fluids. Since syringe pumps are used to deliver medication in less than 1 hour, a conversion factor for minutes to hours is needed unless the program can be done milliliters per minute. So we're looking for milliliters per hour. So in that problem, our fluff is ampicillin 100 milligrams. We don't need that, not for to figure out how fast we're going to run it. We know that's a dose, so we need to make sure that's correct, but we don't need this in this problem. So we need 5 milliliters. We're going to start with milliliters over 15 minutes. And then we need the conversion of 60 minutes to 1 hour. And then we work this out because when we scratch out minutes, we are left with hour and minutes. Hour and milliliters, and we're looking for milliliters per hour. And you work all that out, you would set that pump at 20 mils an hour to get that 5 mLs in 15 minutes. Okay? So just remember the dosage of medication in the liquid is not a relevant part of the flow rate. Okay? So we just need to remember that as we go through these and look at these problems. Calculate infusion and completion times per milliliter per hour flow rates. We do everything in nursing and military time. So when you're calculating how long it's going to take to finish this medicine, you will need to look at military time, and that's in Appendix C, page 439 in the back in your book. If you don't know about military time, please familiarize yourself with that. It's not really hard, but nurses, we use that all the time. Okay, so it's pretty easy if you'll look at it. After 1 a.m. is 0100, 2 a.m. is 0200. It goes all the way up to 12 noon. And then at 1 p.m., it's going to be 1300. 1300, 2 p.m. is 1400, 3 p.m. is 1500. You just have to kind of get that in your head. It's over 24 hours. Or 24 is basically. 2400 is 12 midnight. Okay. So let's look at this problem together. Calculate the infusion time for the IV that is infusing at 100 mils an hour with 300 mils of fluid left in the IV bag. The current time is 11:20 a.m. When will this IV be completed? To calculate the infusion, follow these steps. So we want to set up dimensional analysis, insert the first set of quantities in this example. We have 100. The infusion time is an hour, so we have 1 hour to 100 milliliters, and we see that in our problem. Multiply the first set of given quantities by the second given quantities, the volume remaining. So we have 300 mils. So we have 1 hour times 300, and over 100 is going to give us 3 hours. So to calculate the completion time, though, we know we have 3 hours left to give this medicine. The completion time, if it's 11:20, we're going to add 3 hours, which is going to give us 14:20, which would be 2:20 p.m. Pretty easy, right? So just look at that. So let's look at the note, though. In the first two examples, the time to infuse an IV is in full hours. If the calculated infusion time is in a decimal point, that is a partial hour. Calculate the minutes as well. For increased accuracy in calculating minutes, the infusion time has been rounded to the nearest hundredth. Be sure that you know that it's rounded to the nearest hundred. So calculate the infusion time that's infusing at 150 mils an hour with 800 mils of fluid left. The current time is 6:20. What will be the IV? What will this IV be? When will this IV be completed? So we know that we have it going at 150 mils an hour. We have 800 mils of fluid left. So our infusion time, we are looking for the hour. So we have 1 hour to 150 mLs times 800 mLs will give us, after we divide it all out, 5.33 hours. So how are we going to figure out that 0.33? Okay, so our conversion. We're going to use the minutes. We're going to do 60 minutes to 1 hour times 0.33 hours, and that's going to give us 19.8 minutes, which is going to round to 20 minutes. Okay? So just know that the answer on that one would be 5 hours and 20 minutes. That would be your answer. Okay, so just look through the rest of those. Give you another couple to review. Calculating drops per minute. And see, that's why y'all in the beginning, I know y'all looked at me when I started talking about dimensions analysis. Oh, I can figure that's another way. But when you get to this point, it's too complicated to figure out another way. If you will use dimensional analysis, it will work for you every time, and it will be very easy. Okay, calculating drops per minute flow rate for IV fluids under manual control. That's just the way you're going to control it. It's not that big of a deal, but that's just how this is wrote. So you'll be given a drop factor with manual control. So let's just go on and work a problem. Let's talk about it as we go through. The drop factor, this is in your 1, 2, or 3 under 227. The drop factor of the tubing, which will be found on the tubing package. Standard drop factor for tubing are 10 drops per mil, 15 drops per mil, 20 drops per mil, or 60 drops per mil. The fluid volume to be infused is ordered by the provider. The length of time for infusion is ordered by the provider. So we're going to calculate some stuff here. Let's just look in the example down there in the yellow box. An IV infusion under manual control is behind schedule. The nurse, this is in the yellow box, 227, the example. The nurse estimates that 300 mils are left in the bag. The fluid must be infused over the next 2 hours. The drop factor is 20 drops per mil. No risk factors to the patient have been identified. And why they put that is because some patients can't tolerate you running the fluid faster. If they're already in cardiac overload and stuff, you can't do that. Or if they're in renal failure or some other reason, you couldn't run it. So calculate the new flow rate. So we're looking for drops per minute. So we're looking at drops per minute, even though the tubing factor, we know that drops per minute equals 20 drops per 1 ml. So we're looking for those drops. So 20 drops to 1 ml, 300 mLs over 2 hours. And then we know that we have to find a minute. So 1 hour to 60 minutes, and we multiply this all out. We need to go to 50 drops per minute to get that in. Okay? So just look at the next one, example 1. This is on 228. See how much more we got. We don't have too much more. Okay, example 1, 228. An IV of 1 liter of D5W, half normal saline, is to be infused over 8 hours. The IV tubing has a drop factor of 20 drops per ml. So calculate the drop per minute flow rate. So there again, we want drops per minute. We know that we have 20 drops per ml. We have 1 liter over 8 hours. So what are we going to start with? We know that we have 20 drops. So we're going to put 20 drops to 1 ml times, and then we're going to go to mLs, which is 1,000 mLs to 1 liter. Then we're going to go to 1 liter over 8 hours. And then we're going to go 1 hour over 60 minutes. Are we through? You betcha. Then we multiply it all out because we have what's left after we cross everything out. We have drops per minute, and that's going to give us our drops per minute. Okay. So, and you have to round on drops because you can't count a part of a drop. Okay. The drops have to be whole. All right. So look through those, and I really don't think they kind of seem kind of difficult in the beginning, but they're really not. Okay. Calculate drops per minute flow rates from milliliters per hour flow rate. This is on 230. So let's look at this just a minute. A drop per minute flow rate can easily be calculated from a milliliter per hour flow rate. The only additional information needed is the drop factor of the tubing. So the drop factor of the tubing will be given to you in these problems. So calculate the drops per minute flow rate for a fluid infusion at 100 mils per hour. So we need that to calculate the drop factor of the tubing is 20 drops per ml. So we are still looking for drops per minute. So we're calculating the drops per minute. So we're going to start with 20 drops over 1 ml, go to 100 mLs per hour, and then we're going to add 1 hour to 60 minutes. And are we through? You betcha. And so it'll come out to be 33.3. It's 33 drops per minute. That's not hard, right? Y'all, by this point, usually my classes will say, I got this. I kind of understand it. So it's just knowing where to start, what to start with, and making sure you don't do any silly errors along the way. And if your dimensional analysis is following the pattern, and you've crossed everything out and you're left after you crossed everything out with drops per minute, then you are correct. Okay. Whatever you're asking for, if you're left with that, then you are correct. All right. All right, let's go to 231 down at the bottom. Calculate infusion and completion times for drops per minute. Okay. 232. Calculate the infusion and the completion time for an IV that's infusing at 64 drops per minute. You have 1,000 mLs of fluid in the IV bag. The drop factor of the tubing is 10 drops per ml. The current time is 0200, 2 a.m. So to calculate the infusion time, follow these steps. So infusion time, we're going to look. We know that our infusion time is 1 hour to 60 minutes. We have to start with a conversion factor because we don't see that. And then we need to put, so we have 60 minutes. So we have 1 minute to 64 drops. And then we're going to have what? Our drop factor tubing, which is 10 drops to 1 ml. And then times what? 1,000 mLs. And we're going to calculate that all out. It's going to give us 2.6 hours. So as a flow rate of 64 drops a minute, take 2.6 hours to infuse 1,000 mLs. We must convert that 0.6 hours into minutes. So minutes, we have 60 minutes to 1 hour times 0.6 hours is going to give us 36 minutes. So our answer is 2 hours and 36 minutes, or it will be it's 4:36 a.m. 0436. So y'all look at the next two on here. There's some practice and there's some manual taping, which we're really not gonna get too much into. So that's pretty much it for this chapter. I want you to work on these. If you have trouble, let's call, text. I will walk you through them. Be sure that you work some extra problems and kind of think about it. Y'all don't do this when you're tired. Try to do this, a little bit at a time, because if you're doing this when you're tired, and I know a summer class is probably going to make you tired, but try to set aside time and, only work on about 30 minutes of time, take a short break, and then come back to it, okay? So if you're struggling with it. So your chapter 13 homework doesn't look awful. I want to see what your answers are to make sure you're understanding as we progress, because we're going to be progressing with it. Let me just look over this real quick to see if I see anything I need to go over. I think you'll be more than fine. Follow along with your pages that we just went over. Alrighty.